Hi everyone, good morning. My name is Prdeepta. So I'm going to talk about the data science and its various aspects and about the various methods, uh, the plan, how do we proceed towards this webinar, and what are the aspects we're going to talk in this webinar. So first of all, I'll be explaining the conceptually what is data science and how it is interlinked with various other domains or various other fields where it is used currently. What are the use cases that you can solve using the practice of data science, how it is similar or dissimilar from, let's take statistics, or how it is similar or dissimilar from machine learning. So that's another aspect, and various modules or the training programs that Acadgild offers relating to data science. So this is the plan. So first of all, I would like to explain like what is data science and what are the fundamental concepts or examples of data science that we see in our day-to-day life. So you must have seen, you must be using various applications like maybe Uber, maybe Google Apps. So there are various applications. So every day we are using a lot of applications on our smartphones. Now, using our smartphones, we could do all those things like booking a cab, booking food, or ordering food online. So there are various things we are doing. Now, we won't get to know that there is a set of algorithms behind it, which is triggering the recommendations, which is triggering the ordering process, and which is also helping us to navigate whatever whatever we're liking. So for example, when you are studying or whenever you are looking at a particular application, whenever you are looking at something, so behind the scene, so the intent prediction is going on. So the data tells user that this is something which you want. So let's start with, first of all, what is data science and what are the interrelated fields? So data science is basically, it's an interdisciplinary field where we can see various other sub topics or sub concepts are associated with it. For example, like machine learning, data mining, pattern recognition, math and starts, predictive modeling, exploratory data analysis, big data solutions, etc., etc. So various topics. Now, in this slide, you can see a lot of concepts associated with it, and it's a cycle. So in this cycle, what we're trying to do is like, so it's a field, the data science is basically a field of extracting insights from the, okay, what is data science and how it is interlinked with various different fields. So basically the data science is, as I said, it's a scientific method or process or set of algorithms. It consists of, and to extract the knowledge or insights from data, and the data can be data can be present in various forms. It can be present in the form of a structured tables or unstructured data as well. So whether it is structured or unstructured, the objective is to get insights from the data. The objective is how do we get actionable insights from the data. So the data science is it's a concept which includes the statistical methods, the mathematical approaches, to implement the algorithms in such a way so that we can utilize the information hidden in the data to take business decisions. So basically, it employs the techniques and the theories from various fields like information science, computer science, mathematics, and statistics. So here, various concepts. So it starts with the domain expertise. Why? Because you need to know, like in various domains, like it has various KPIs or key performance indicators or various metrics that organizations follow. For example, in an aggregator website where like you're booking tickets or you are booking movie tickets or you are ordering food. So these are like aggregators. So in the backend, there are so many suppliers who are offering the services, and there is one intermediate layer where the user is interacting with the suppliers to place the orders, and the orders are getting fulfilled. The user is making the payment. Now the question is, what are the metrics that is driving this? Okay, what are the metrics that is driving it? So the domain expertise is very important and it is required. Then comes the business analysis. So in domain expertise, you need to know the metrics that drive the business and how those metrics are computed. And for example, this aggregator side, you have to look at a ratio called a look to book ratio. The time taken between the moment you look at the product and the moment you make the payment. The time differences is called the look to book ratio. Now, some people, they will book it so quickly. Some people, they will book it maybe after some time, maybe like 30 minutes gap or maybe 45 minutes gap. So that's called look to book ratio. So from the domain expertise side, it is important to understand, right, the key metrics or the performance indicators of the business. So domain expertise is required. Then comes the business analysis, when you have to look at how the metrics is performing, whether it is improving or it is diminishing over the time, or it is how it is behaving, how it is performing. So this is also important. Then stakeholder management. So while doing stakeholder management, so stakeholders could be the senior management, stakeholders could be the client, how the business analysis is impacting the stakeholders. For example, the key performance indicators are increasing. So this is a message for the stakeholders. Should they reduce their expenses on various heads? Should they align their resources to some other field? Should they expand their business in some other domain? So these are the messages to the stakeholders. Then the storytelling ability. Storytelling ability means you have to explain what is going on in the business, whether the metric is increasing or decreasing, why it is increasing, why it is decreasing, what are the factors that causing the increase or decrease. So you have to identify those parameters. So storytelling is the ability to relate it to the existing situations and to relate it to the existing circumstances and how things are connected. And you have to tell the complete story from the very beginning, that this is increasing because of this factors, and these factors are related in such a way. Then after storytelling, the business communication. So the communication is basically strategy. So how do you strategize the findings from the data? Then consulting. So you have to tell the stakeholders that what action to be taken. As a consultant, you have to tell them that what need to be done or how the things can be made better if some things are not right. If certain things are going correct, then what are the other options? How do we leverage the existing things, right? And then comes the typical like analysis and problem solving. So as I said, the data science is a combination of various other fields. Okay, so that's the beginning. And who are actually the data scientists? So the data scientist is like somebody who again looks at the data, who looks at the data in such a way, like in an investigator, or you are just investigating the data and you are telling that what is happening, why this is so. So basically you are an analyst, you're looking at the data sets. Now while looking at the data sets, you are always in a curiosity to find out something new, to find out some unusual patterns, which is maybe something new, right? So a data scientist is basically wearing hats of like 3 or 4 people. He is basically a hacker, which hacker means, and you have to find out the programming skill sets, the hacking skill sets, to find out or in a smart way, like what is hidden in the data. An analyst, he should be able to explain things. A communicator, who should be communicating the findings to the business stakeholders in such a way so that the business stakeholders understand what is going on. And an advisor, that means you are in a consulting role, you are consulting the business that what should be done and what need to be done. So you are basically helping the decision makers or the business stakeholders to take relevant decisions for their business. How to become a data scientist? Now, in this case, it is important to start with the domain expertise. And if you do not have any domain expertise, let's take you are a beginner into data science, or maybe you are a fresher. So the first step in learning data science would be start learning a business. It could be manufacturing, it could be insurance, banking, retail, etc., etc. So to do research, the domain expertise will come from research. So research is basically finding out certain research papers on those domains. The popular sources of research papers could be the Google Scholar. You can find online also, there are various other repositories, resources where you can find the research papers. So find the research papers relating to those industries and try to find out what is going on and how the industry is performing, what are the challenges the industry is facing, what are the major problems in those industries. So that will help you in gaining the domain expertise. So the domain expertise is basically understanding the terminologies, the methodologies, the techniques, or relating to a particular domain, and understanding what impacts the business in this domain, right? So for example, if I take a very unusual domain, let's take a cracker business. Cracker business is a very seasonal business. So this comes like maybe during the month of November or December every year. The cracker business is like it's a peak time, but throughout the year there is some demand, but which is highly local, so the demand would not be very huge. Now how to make those people who are in this business be profitable, right? So to understand that business, again you have to understand like where they are getting resources, how they are making it, what are the costs involved in this, and how they are making profit, and what are the levers for making profit, etc., etc. So like that, any business, whether it is online or offline, the business must be driven by some levers or some pointers. Now you have to identify those levers and that impact the business. So that's why the domain expertise is very much essential. Now, once you have understanding about the domain, then next step would be understanding the statistics or mathematics part of it. Now, when you understand the business problem, then you have to convert it to statistical or mathematical problem. So while converting the business problem to a math or stat problem, again, you will be fitting the math or stat problem to one of the distributions statistically if it is present. Because if you can fit a data to a kind of a distribution, then you can estimate the parameters, and then you can start predicting the probability of happening or not happening of an event. Now, to associate a data point to a particular distribution and then making relevant predictions about the probabilities is a skill set. Now, to do that, you have to understand all the possible probability distributions. Now, statistically, the leading probability distributions, that is fine. So these are like normal situations, but there are some unusual probability distributions that fits into a specific scenario. So you have to understand all the statistical distributions and try to fit into some kind of like mathematical or statistical problem. So here you convert the business problem to a math or stat problem, then you look for distributions in statistics, or then you look for theorems in mathematics that can help you in getting an answer to the mathematical problem or statistical problem. Now, once you get the solution mathematically or statistically in a small scale, then you would want to automate the whole process, right? Because here you got the solution, like maybe simple like pen and paper, you just got the solution. This is how I can solve this problem using a mathematical theorem or a statistical probability distribution or a statistical model. Now, once you get it, you have to deploy that, right? To deploy that, you need a programming skill set. So to deploy, you have various options. Of course, you have Python, R, Java, Scala. So there are various other programming languages that support this kind of functionalities. So then you will look for the relevant functions. Suppose I have used, let's take a negative binomial distribution in statistics to predict some probabilities of an event. Now, which type of a tool or programming language provides the API for doing like a negative binomial distribution? That is something which I have to search. Now, once I find, okay, how do I scale it up? If I have to apply this on a large scale data, how do I do it? Should I go for Java? Should I go for Scala? Should I go for Spark? So what are the tools to do that, right? So you got the domain expertise, you understand the business problem, you convert the business problem to a statistical or mathematical problem. Now you find a statistical or mathematical distribution or theorem that can solve the problem. You solve it in a small scale, like simple pen and paper. Then you extend this to automate the entire whole stuff. You need to look for programming languages. You got a programming language, you do a testing, you do a build, you test it out, it is working fine. You want to deploy it, then you go for how to scale, how to make it scalable and make it a deploying it on a large scale data. Then you go for big data tools. Here, you will be pulling the data from large scale data lakes, or maybe large scale data storage or data warehouses. And how do you call those programming written in Python, Java, or R? How do you deploy it on large scale data? So once you deploy it on large scale data, then finally you got the output. Now this output you want to visualize. To visualize the output, then you have four different options: Tableau, ClickView, SAS, or Excel. So These are various ways. The most convenient way is to show it in Excel or Tableau, so which is user friendly and you can explain it to someone. So this is the overall structure or roles and responsibilities of a data scientist. So who is like holding a multifaceted hat. So multifaceted person who is like taking care of the data from end to end. How to do data science? So now in this space here, so first of all, the person has to learn the data warehouse part of it, where here, if you look at this particular slide, so there are three typical roles. At the right hand side, if you see the data engineer or data analyst kind of profile, and data engineer would be taking care of the data warehousing part. So you have various devices, you have applications, so you have desktop applications, Android app or iOS applications, like mobile or smart device applications, and then you have device data as well. So from different sources of data, how do you gather the data and how do you push the data to the data warehouse? That is the role of a data engineer. Now, the extraction role, sometimes the data extraction and to answer the business question and to do exploratory data analysis to find some meaningful insights or graphs or charts, that is basically the data analyst's job. However, the data analyst is also one of the role that data scientist has to adopt. Now, as a data scientist, you are doing the same data extraction, exploratory data analysis, and along with that, you are looking for algorithms that solve the business problem. So basically, you are using the model building, algorithmic model building, so the data scientist is doing, and then product engineering. So where the data scientist has to integrate the algorithm that he has built to the product, right? So to write the programs in two different places, so here you have two different tools. The most popular tools are Python and R. R is a programming language where it's very user friendly and you have a huge list of libraries, like around 10,000 plus libraries you have to support various functionalities, and it provides various APIs where you just have to define the data set and you have to provide what to do in the syntax, and in the backend the entire program is coded and you just have to execute this, right? So R is user friendly, so anyone with minimum effort, maybe around 20-25 hours of training, so you can cover the R programming. Now 20-25 hours is maximum like from a personal front. But from learning perspective, I think like 5 to 10 hours is more than enough to learn the R programming. But later on, you should always keep keep improving the skill sets that you have used in using R. So either you have to learn the R language or you have to learn the Python language. So when I compare the R and Python, so it's not R versus Python, it is R and Python. So you would need both the tools. Certain places or certain tasks you want to quickly deploy, explore something and some insights you want to extract, you should go for R. Now you want to build something which is you want to build something like stable, which will hold for future deployments as well. You want to integrate in the products or you want to give it as a solution. So you should go for Python programming because Python has extensible libraries, and you can connect Python libraries to almost any other tool in data science space. So it's quite flexible and the syntaxes are very easy to learn. So then you can use Python also. But again, to which tool to choose, that is your call. So you have to decide which one you have to basically, like if you are from a programming background, you would like Python. If you are not from a programming background, then you possibly would like to learn R. So if you are from programming background, then Python is good. So you will be feeling little comfortable because both the languages are object-oriented programming languages. However, Python is more flexible. And if you are from a programming background, now if you are from a non-programming background, then R would be the best tool because here the syntaxes are very easy and it's not highly programming kind of thing. So where it's highly dependent on syntaxes. If you know the syntaxes, it's pretty easy, and it will help you to write. Basically anyone can understand R. Anyone can learn R. So just minimum effort, like 8 to 10 hours, if you spend on R, you are pretty comfortable in R. You can easily do. Python will take a little more time because you need to understand in the backend how exactly it interacts with the computer and how it interacts with the system. So once you understand this, then Python will also be easier, a lot more easier. But Python is more of like for deployment, it's pretty easy. So ideally, I would say you should go with both. Certain places where you will be using R, certain places where you will be using Python. Okay. Now, coming back to statistics. So school level statistics, like correlations, regressions would be required. That is the base. And subsequently, if you have understanding till, let's take the descriptive statistics, correlations, and linear regression, I mean, that's a good starting point. Then you can understand easily all other aspects. So statistics wise, so three things would be required: probability, distributions, statistical hypothesis testing, that is inference analysis, and the models, the linear models. So these are like basics which would be required, and on top of this, then you will subsequently learn. So this is the fundamental. Now, if you know those basics, and even if you don't know those basics also, that is absolutely fine. So there are some primers. It will start from the very basic, saying that what is statistics, so we can just do a refresher of the statistics that is required for data science, for learning data science. And here you'll be looking at the basic statistics, how to interpret the results, how to deploy the basic statistical things in a practical use case, or how to use statistics to answer the questions in a business scenario. So those things we can cover. Then comes the data visualization tools. In data visualization, here you want to communicate the results to the stakeholders. Now there are two kinds of visualization. One is input data visualization, one is the model results visualization. So if it is input data visualization, you are not doing any kind of mathematical calculation, statistical calculation, or you are not doing anything like you are not doing any calculation. It's simply as is. So you are storing the data. You just want to display the results, what is there in the database. So it's simply the input data visualization. You are not doing any kind of like output visualization, which is output visualization is basically the model results. You have built something and you want to show the results. So these things can be done using Tableau, ClickView, or Power BI. So these are three different tools that is existing, again, depending on your comfort factor. If you're comfortable in Tableau, so good to go. If you're comfortable in Power BI, good to go. So the most popular is basically Tableau is most popular because like many people, they use it and it's a comfort factor. Once you are used to a certain tool, then you will feel more comfortable and it becomes a norm. So people will follow that, right? So it's about the comfort factor. So you can explore all three tools and you can download their trial versions and see which one is more comfortable with you. And these are like a self-exploratory tools. It will it doesn't require any formal training also. You just have to download the trial versions and you have to experiment with that. You load a CSV file and you just play around the tool, and there are user guides also, the self-sufficient user guides. You can download those user guides and you can go through it. So it's like just spending time on Tableau or ClickView or Power BI to learn how the tool works. So this is about data visualization, and the skill sets would be required for data visualization is like no formal skill set would be required for data visualization. It's the way you imagine the results to be displayed. It's the way you want the results to be shown to the users. And the users can be the stakeholders, the users can be the business users, etc. Right? So the next topic is about how to learn the machine learning. So the machine learning is the most important skill set right now in the market. So what is machine learning? So machine learning here is that like you want the machine to take a decision on what type of a model would be required for the problem statement and the input data that you are providing to the machine. So to define it, there are three concepts: performance, task, and experience. If the performance of any task improves over time by learning new experiences, that is called a machine learning system. So a machine learning system starts with the input data that is called experience. It tries to model the data and it tries to fit to a performance criteria. The performance criteria can be the accuracy, can be the stability or reliability. So If based on the performance criteria, the input data is used through an algorithm and your algo produces better performance and the performance improves over time as and when you add more records to the data set, the performance keeps on improving. Now that becomes a perfectly machine learning. So the objective of a machine learning system is to improve the performance of any task. The task can be a classification task, the task can be a regression task can be a recommendation or forecasting. So you look at the task, you design the problem into a statistical or mathematical problem. You define the performance criteria that how would you evaluate the model or how would you evaluate the or assess the performance of this mathematical or statistical model. And once you have the performance criteria set, now whether the performance is improving over time or it is not improving over time, you keep a track of like how it is improving over time by using some kind of a threshold criteria. Now, if it exactly improves by learning new experiences, and when your data size increases, the performance also increases. Now that becomes really your machine learning system. A machine learning system would require initial set of data and then the algorithms that learns from the data and then the output it produces, whether the output is acceptable or not. The acceptability is defined by the performance criteria. So if certain things are acceptable because it meets the performance criteria that you have already set, then you can say that my system is learning, my machine is learning. So that becomes your real machine learning system. So any machine learning system, whichever is not like, and we are seeing a lot of applications today. Even people call linear regression also a machine learning technique. Logistic regression is also a machine learning technique. So if I'm looking at a machine learning technique and I'm manually updating the accuracy and I'm changing the parameters, etc., that's not a learning system. How do you automate the entire learning system? How do you ensure that the algo is learning from new inputs? Now the algo is predicting the output better and better in like every day, on a daily basis. So if a machine is not learning, the algo is not improving the performance, the algo performance is not improving relating to a particular task, then that's not a real machine learning system. There is no learning element in this machine learning, right? So any machine learning system should have the ability to learn, adapt to the new data sets, adapt to the new adapt to the changes that is happening in the raw data or input data. So that becomes your real machine learning system, right? So next step is about domain expertise. So in domain expertise, I have already spoken about the domain expertise. Here, the domain expertise, why it is required is that what to model. Because here you need to understand the key business metrics. Maybe it is retail, banking, pharmacy. So whichever domain you may talk about. So each domain has its own nuances. Each domain has its own problems. So if you just do a Google search on finding out, okay, what are key problems in the, let's take retail industry, right? So existing problems in retail industry, if you want to find out, then it will show like long list of problems that exist. And how do people solve it? You'll also get a reading around this, like how people solve it. Then comes the innovation. If people solve it in such a way, and if that is a problem, then can I solve it in any other unique way, which is not existing now? So that's how the innovation comes into picture. So if you understand the domain really well, then you can think about innovation. You can think about how you can make the process better. That's why the domain expertise is very much required. Now, this slide talks about the typical steps that people take in the data science projects. You understand first the business. So before hitting to the data set, you understand the business like to the core. So there is one open source competition going on. Maybe it is predicting the housing prices of Bengaluru or something like that. So online it is going on. If you look at the data set, it's not much, it's not giving like a straight out the information. Okay, here this is the X variable, this is the Y variable, you go ahead and predict. No, it's not the typical scenario. If you look at the typical business problems, They will just give you, this is the data that you can use. This is my business problem. You have to frame the data in such a way it is compatible for an algo to be run. So in order to do that, what are the typical steps or processes people follow? So first the step is understand the business problem, set the goals. Now here the goal is to predict, let's take the housing prices. Then what data set I have available like with me. So collect the data. If data available, clean and clear, go ahead with this. If data not available, collect the data. So then you will look at data cleaning procedures, data exploratory analysis, EDA part of it. You have to understand the univariates, bivariates, multivariates, how things are connected. Then if data cleaning, further data cleaning is missing value imputations, outlier treatments, so correlations, understanding the correlations, associations, etc. You do exploratory data analysis, then you search for the models. Which models can help me answering the goals that I have set in the step number 2. So you find out a model, then once you model the data, then you try to find decisions points. So my model tells us this is something is predicted. Now what should I do? The model tells us this is something which need to happen. This is something which is classified. Then how do I make decisions? To make further decisions, you refine the findings through feedback. You ask the person, okay, whether this is the predicted value is correct or not. No, the predicted value is not right. Okay, go back and make changes in the data that you have collected. So this process would go on. So these are like typical steps in data science, right? Now, how it started? So the journey started with reporting. So maybe if you look at the 90s or 2000s. So during 2000, 2005, so people were building devices and they were building the reporting tools. So that gives the business intelligence. This is just about information. Then you have the prediction, which is using the machine learning or using the statistical models, you are predicting the future. The next evolution is about creating the future, which is the decision points and recommendations. You are telling the business what need to be done. Then the future is basically the artificial intelligence, which is a combination of data science and machine learning, and you are generating intelligence in such a way that before the event happens, the user would get to know that what is likely to happen. So you are bringing some certainty to the uncertain future environment, so that you are providing not just information, but in an intelligent way you are providing the information. That's why you are gathering artificially the intelligence for the user to make business decisions about the future by making use of data sciences, machine learning, and the statistical models. So then these are the courses or which Acadgild provides. So it's the data science course here is like 24 weeks intensive program, 120 mentoring hours, 500 plus coding hours, 10 to 12 industry level projects. The syllabus includes Python programming, data wrangling techniques, statistics and probability, machine learning, Spark, like big data processing, deep learning for processing larger data sets and using complex models, right? This is the course structure, and the course module is designed in this way. Fundamentals of Python, so you'll get to like there are 5 different sessions on fundamentals of Python basics. Data wrangling, so you are looking at SQL, you are looking at pandas, data operations like data management, data munging, etc. So it's around 9 sessions. Statistics and probability is about 4 sessions on this. Then ML models, the machine learning models using Python. Then again, deep learning models again using Python. It's 8 sessions. Big data with the Scala and 6 sessions. The project's course structure is the case study on the data wrangling, predicting the players' ratings. This is one of the data set. And this project, the next project would be application of the classification models. Project 4 is application of clustering models. Project 5, application of time series models. 6 is about deep learning, that is image classification. And the 7th is basically the natural language generation or TV script generation. Typically 7 projects. that is part of the data science course. And other courses are of course there, so specific to big data. So Acadgild also provides a data analytics course with R, Excel, and Tableau, and analytics for non-programmers, big data, etc. This is the data analytics course details. Specifically, the big data engineering is also a separate course. This is data analytics with R, Excel, and Tableau. So this says the specific attention to each of the tools and projects, and the session distribution also you can see here, how focused it is towards specific tools and how it makes the user to learn those tools. This is for non-programmers. This is the big data engineering part. So the projects involves like various domains. It includes supply chain management, healthcare, e-commerce, finance, banking, and retail. So that's about, so here, which tool used for ML? Sure, I'll looking at the functional knowledge. It is important. We look at banking. Banking is not a small thing. Like banking has thousands of things in it. For example, corporate banking, retail banking, loans, credit cards. Then if it is loans, then housing loan, personal loan, business loan, car loan, auto loan, heavy auto or heavy vehicles loan, then corporate loan. So there are so many things in this business. Now each entity in itself is a separate business within a bank. The home loan department is completely different from retail banking. Retail banking is different from business banking. Business banking is separate from corporate banking. So there are so many divisions here. Now, if I say to, like, let's take how, why people are not taking so many home loans from a particular bank. If the bank has to understand what are the factors that leading that people are not taking loans from a specific bank X, how do you identify that? To know that, you need to have a domain knowledge of how the bank functions, what are the different divisions, how the divisions are interdependent. You need to know that. So that's why domain expertise is very much essential. Thanks. Bye-bye.
Acadgild. Average is dead.